like a waterfall in slow motion.
This is the concept video for variation of parameters. So this is another technique to solve inhomogeneous second order differential equations of the form y double prime plus p y prime plus q y equals f of t, where f of t is the forcing term. So this is an inhomogeneous equation. This is inhomogeneous, and what we do is we again look at the associated homogeneous equation, which is yh double prime plus p yh prime plus q yh equals 0, which has the solution yh equals c1 y1 plus c2 y2. So what we do is now we assume well, we again have our complete solution. So the solution to this is yt equals yh of t plus yp of t. We assume that yp, our particular solution, is going to be v1 y1 plus v2 y2, where y1 and y2 come from the homogeneous solution. So v1 and v2 are going to be functions of t. So I'll make that more clear. So what we do is we need to find v1 and v2. The way we do that is we solve this system of equations. So to find v1 and v2, we can't directly find v1 and v2. We can find v1 prime and v2 prime and integrate. So we solve this system. v1 prime y1 plus v2 prime y2 equals 0, and v1 prime y1 prime plus v2 prime y2 prime equals f of t. So I won't go into why this system gives us v1 and v2, or v1 prime and v2 prime. We're just going to assume that it works, and it usually does. So if we write this in a matrix form, we'll have y1, y2, y1 prime, y2 prime, and 0 and f of t. So this matrix is actually the Wronskian of the two functions y1 and y2, if you notice, but that's not that important. So this gives us v1 prime and v2 prime. And then our particular solution is v1 y1 plus v2 y2. So we need to integrate to find v1 and v2. So our total solution y of t is equal to c1 y1 plus c2 y2 plus v1 y1 plus v2 y2. If we can go ahead and explicitly solve this to give us a formula for v1 prime and v2 prime, or v1 and v2. So v1 is going to be equal to the integral of negative y2 g, or sorry, not g, we're using f of t dt over y1 y2 prime minus y1 prime y2, and v2 of t is going to equal the integral of y1 f of t dt over y1 y2 prime minus y1 prime y2. We can simplify this by using the Wronskian, or the determinant of it. This is the Wronskian of y1 and y2 on the bottom. Sorry, that should be a t. And that is all there is to variation of parameters.